Okay, this is 2015 FRQ number 5. So it says the figure above shows the graph of f prime, the derivative of a twice differentiable function f on the interval between -3 to 4. The graph of f prime has horizontal tangents at x equals -1, x equals 0, and x equals 3. What that tells you is that you have a slope of 0 here, the slope is 0 here, and the slope is 0 here. That's the whole point of telling you that it has a horizontal tangent. All right, so m equals 0, m equals 0, m equals 0. All right, great. The areas of the region bounded by the x-axis and the graph of f prime on the intervals between -2 and 1. Okay, so between -2 and 1, so it's right here. Remember, it's trapped between the x-axis and the function, between the function and the x-axis. So that area is 9. Well, it's really -9 because it's below the x-axis, right? And then it says between 1 and 4. So this region right here is going to be 12. It says 12, so -12. All right, so that's good to know. All right, so again, I'm writing down all the information is provided for me. Find all the x-coordinates at which f has a relative maximum. Give a reason for your answer. So again, this is a graph of f prime. So what you want to know is that since this is a graph of f prime, to look at f, you're looking at the area under the curve. Right? Oops, there's one curve. Yes. F prime is the function that we see right now. And then if I want to look at f double prime, I'm looking at the slope of the function. Right, so a little bit different than what we saw before, which we saw g of x being defined as a part of f. But this time we didn't want to go that far. We just said, okay, this is a graph of f prime, this is a graph of velocity. Use this to figure out what the original function f looks like, okay? So let's answer a few questions. It says, the first question says, find all the x-coordinates at which f has a relative maximum. Give a reason for your answer. Okay, so when we're looking for maximum, you gotta remind yourself, how is a maximum created? A maximum is created when a function has an increasing derivative changing to a decreasing derivative. So this is when f prime went from increasing to f prime decreasing, therefore creating a maximum, right? So it goes up and then comes down. So what does it mean when f prime is increasing? That means f prime is greater than 0. So in my picture here, that's when the function, the graph above x-axis to graph below, sorry for the terrible writing here, below x-axis. So meaning I change my sign, I change from a positive to a negative, right? So, and also the graph itself has to equal 0. So when is the graph equaling 0? Well, it equals 0 right here, equals 0 right here, and it equals 0 right here. Now, we don't take into account the last one because there's nothing happening after that. So you don't know whether or not the graph is changing in terms of the sign. So that point is not useful for me. The point at 1 is not useful either because the graph stayed negative to negative. I am below the x-axis before and after. So the only one that is useful for me is -2 because the graph was positive here. It's above the x-axis. And it changed to negative here below the x-axis, positive to negative. So I would say f prime was positive when x is less than -2, and then it is negative when x is greater than -2. So because of these, you have a maximum at x equals -2. And that is your reason for your answer, right? So again, you need to talk about the fact that it changed signs, or it went from increasing to decreasing, or rather it went from positive to negative, okay? All right. Part B, on what open interval contained in -3 to 4, so in this picture here, oh, by the way, I'm going to erase what I had here so I don't confuse myself, is a graph of f both concaving down and decreasing. Give a reason for your answer. Okay, so again, let's ask yourself, what does it mean to be concaving down? So concave down means that f double prime is negative. Right? So in our picture, if I'm looking at f double prime, I'm looking at where the slope is negative, meaning the graph is going down like this, right? That's the concaving down. And then you're looking for decreasing. Decreasing means that f prime is negative. So that means the graph we're looking at, because this is a graph of f prime, is below the x-axis. So not only are we looking for a negative slope, we have to be below the x-axis of both of these, right? So let's take a quick look. Where is my graph below the x-axis? Well, lots of region here, right? Everything here is below the x-axis. So where below the x-axis is it also decreasing in my slope? So is my slope negative? Well, it's negative here from -2 to 1, -1, and it's negative here from 1 to 3. So those are the only two intervals that are both below the x-axis and the slope is negative. So what open intervals are those? That is from -2 to -1 and from 1 to 3. And again, what I've highlighted in green here is sufficient to explain to you that, oh, this is why we chose these intervals, because these intervals have both a negative slope and the graph is below the x-axis. So this is my answer, my two intervals. Okay. Part C, find the x-coordinates of all points of inflection on the graph of f. Give a reason for your answer. So for point of inflection, that's when f double prime equals 0. Right? Again, in this picture, that means the slope of this graph is equal to 0. But most importantly, in order for it to be a true point of inflection, not only does your slope have to be 0, your f double prime have to be 0, your f double prime has to change signs. It has to change concavity from a positive concavity to a negative concavity and vice versa. So it means that f double prime, furthermore, like additionally, your f double prime has to change sign, which means your slope has to change. So not only does the slope have to equal 0, slope has to change before and after. Okay, so we know when our slope is 0. We had those 3 points where my m equals 0, right? Okay, so let me erase some of the stuff here that I don't want to be confusing myself. Okay, well, we have those 3 points there that the slope is 0, but then we want to know that the slope changed before and after. So the slope before this point here, a -1, slope was negative and it changed to positive. Okay, this is a good point of inflection. Right here at 1, slope was positive to negative. Point of inflection, great. Here, slope was 0. Before it went negative and it went positive. Oh, so I actually have point of inflection at every single point here because the concavity changed every single time. So I can explain that the slope, change signs before and after at x equals -1, 1, and 3. So these are your point of inflection. So these are point of inflection. Of course, on the AP test, you want to make sure you write it all out. Right now, I'm just trying to save time for you so you can see how to do this quickly, right? Okay, for part D. And I think this is good enough answer, good enough explanation. You can look at the key and see how little you need to explain, okay? All right, given that f of 1 equals 3, write an expression of f of x that involves an integral. Find f of 4 and f of -2. So given that f of 1 equals 3, this is how you need to set up your equation. Your f, remember we talked about this being the initial condition. So it means your f is equal to the initial condition of 3, that's your y value, plus now the integral of 1 to whatever x value of your f prime. Okay, so again, that's how you write this equation. Typically, in the past 3 FRQs, we've been using G, but this time we're using F. Okay, so we're looking for f of 4. So what does f of 4 look like? F of 4 equals 3 plus integral of 1 to 4 of f prime. Okay, now is 1 to 4 a good is 1 to 4 a good interval? Yes, because it goes from small to big. So we don't need to worry too much about that. So we look at 1 to 4 up here. Between 1 to 4, my integral is -12, right? It's a negative because it's below the x-axis. So it's going to be plus -12. So my final answer is -9 for f of 4. That's the first answer. Second one's looking for f of -2. So f of -2 is equal to 3. Initial condition of 3. Plus the integral of 1 to -2 of f prime. Now we have a problem. We can't go 1 to -2 because it's not small to big. So remember, we can switch our interval around by making a negative or adding a negative to the integral. So it's 3 minus -2 to 1 f prime. So now it's 3 minus, what is -2 to 1? Well, from -2 to 1, my area is -9. So it's going to be 3 minus a -9, which gives us final answer of 12. Okay? All right, that's it.